Welcome to the section on semantic segmentation with TensorFlow. Image segmentation involves taking an image like this and then generating an output which looks like this. And this generated output is built such that wherever we have an object, like in this case where we have this cat, we have a different pixel value for all the points where we have the cat located in the image. So this pixel value is also uniform across all the different points in this object. Now this means that if we had, say, 2 or 3 objects here, we're gonna have 3 different colors for those 3 objects, but the same object is meant to have the same color. In this case, the cat has this yellow color, then its boundaries have the color red, and then the background has a color, in this case blue. For the example of this dog, we have this dog having this color yellow, its boundary the blue, and then the background this blue right here, or rather the boundary the red, and then the background the color blue. So in this example where each of the pixels represent a 3-channel RGB, here each pixel can either be this yellow, this red, or this blue. Now the yellow, we could consider it to be, say, a value of 0, then or a value of 1, the red a value of 2, and then there's a value of 3. Or we could consider this to be a value 0, this 1, and this 2. What matters is that they should all have 3 distinct values. Also note that unlike here where we could get values ranging from 0 to 255, with this each pixel has just or can take just 3 values, that is 0, 1, or 2. So we have this, and then this. And also, since we're used to working with one-hot representation, this 0 can be written as this vector 1, 0, 0, where we have all zeros and the 1 is located at the 0th position. The same here where all zeros and the 1 is located at the 1st position. Here all zeros and the 1 is located on the 2nd position. The dataset we shall be using in this section is the Oxford IIIT PET dataset, which you could get on this link. The Oxford IIIT PET dataset was developed by Omkar Paki, Andrea Verdaldi, Andrew Zimmerman, and CV Jawahar. This is a 37 category PET dataset with roughly 200 images for each class. Here we have the 37 different categories ranging from the American Bulldog, American Pit Bull Terrier, right up to the Sphinx. And each of these categories have 200 images in this dataset, making a total of about 7,349 images. This dataset is also broken up into 2 main categories. That's the cats and the dogs. Here we have the dog breeds, and then here we have the cat breeds. The dataset can be downloaded via this link right here. So with this, we have the images and then the annotations right here. These outputs are said to be tri-maps because we have 3 different pixel values we could obtain. So this mappings are outputs, and here we have the inputs. After downloading, we have those image files right here. We see the different dog and cat breeds. And then we have the tri-maps, which are the annotations. Let's visualize an image and its corresponding mapping from the data set. We have this image right here, and then its corresponding mapping, which is this right here. So we have that, we run this, we get this. So this is the image and this is corresponding mapping. We are now set to prepare our data. We shall use a data generator to come up with our inputs and our outputs. And this data generation function right here, what we do is we load the image, which is this, from this images. The images is the main folder, and then we select a particular image. we load that image, we convert that image into an array, and then we append it to this list X. Then we'll do the same for the mappings. We have the map, we have the specific mapping, we load that into this Y. Note that the color mode here is grayscale, and then the target size is the input dimension divided by 2. So if here we have an input dimension of 224, this target size will be that of 112 by 112. Then once we obtain a given batch, we now have this X and Y, which represents a given batch, input and output. What we'll do is we subtract the values of the input by 1. The reason we do this is because the dataset comes as such. We have 1, we have 2, or we have 3. But then the way our models work is that they're taking values starting from 0. So we shall send this 1 to a 0, and then we'll send the 2 to a 1, and we'll send the 3s to 2s. So that's why here we have to subtract 1 from each of these values in the mappings. So this means if we have an output which is like this, let's print this out. So we have this kind of output where everywhere we have a 1, we suppose there's an object. Where we have a 2 is a boundary. Where we have a 3, it's the background. So once we have this, and then we do this, so we subtract 1, we could now print this out, print out Y. You see, we push all these 1s to 0s, 2s to 1s, and 3s to 2s. So that said, we're done with this path, we're done with this generator. We can now define this images and maps folder. What we've done again here is we've broken up the images and maps into the train and then the validation dataset. Our train dataset has 6,000 images and our validation has 1,390 images. Batch size of 4, learning rate 1 times 10 to the negative 4. We could take this to this. Number of epochs 1,000. Input dimension 224. This number of filters, we shall see this when we'll be defining our model. For now, let's just work with this. So we run it, and then we'll define our train generator and our validation generator. So it's basically this data generator right here. We now pass in the train images, train maps, the validation images, and the validation maps. So that's it.